Good day, everyone. I am Julian Paragatos.
And I am Rizabella Pahanonot from Bachelor of Science of Architecture 3A, and we're here to discuss to you our report in Building Utilities.
Alright, so let's start. Building Utilities R3532. So this is the chapter 1, Principles of Electricity. So first, let's
Discuss about
what is principle. A principle is a general scientific theorem or law that has numerous paid applications across a wide field. So
the highlight part of principles is the scientific theorem or law, and that has numerous special applications across a wide field. Here are the topics of Topic A, the Chapter 1, Principle of Electricity. First, we have electricity energy, and second, the unit of electrical potential, the volt. Third, the unit of electric current, the amphere. Fourth, the unit of electric resistance, the ohm. And fifth, the Ohm's law. And lastly, the circuit arrangements.
Lesson 1, Electric Energy.
Electric energy. Electrical energy is the power an atom's charged particles have to cause an action or move an object. The movement of electrons from one atom to another is what results in electrical energy.
So, electricity constitutes a form of energy itself which occurs naturally only in unusable forms such as lightning and other static discharges, or in the natural galvanic cells, which cause corrosion. The primary problem in the utilization of electric energy is that, unlike fuels or even heat, it cannot be restored and therefore must be generated and utilized at the same instant. So let's proceed.
Ready, go!
Next topic, we have here the unit of electric current, which is the ampere.
An ampere current flows in a conductor when 6.25 times 10 raised to the power of 18 electrons pass a given cross-section in 1 second.
Current or amperage is a abbreviated amps or A on 120 volt service. The ordinary 100 watt lamp filament carries about 0.833 amp. The motor for a desk calculator, about 1.00 amp current, is represented in equations by 1.
So an electric current is the stream of charged particles such as electrons or ions moving through an electrical conductor or space, wherein the SI unit of electric current is the ampere or amp, which is the flow of electric charge across the surface at the rate of 1 coulomb per second. So let's proceed.
So these are the figures of hydraulic analogy.
So hydraulic analogy is an invisible and the process in play in electronics are often difficult to demonstrate. The various electronic components are represented by this.
Example, the switch goes to the battery, produces voltage, and to the current goes to the resistance. And go back to the switch. So you'll have the hydraulic analogy.
So resistance means is a measure of the position to current flow in an electrical circuit. So yeah, that's it. Let's proceed to the another one. All right. How is ampere calculated? Ohms equals watts, or what we call wattage, and volts. Partner, will you discuss what?
Yes. So how is ampere calculated? Wait. So how is ampere calculated? Ampere calculated by ohms equals watts or wattage over volts. For example, we have 4,160 watts and 208 volts. So to get the ampere, you just divided it, and yeah, if you calculate it, you're going to have 20 amps. Simple, right?
Next is the unit of electric potential volt. The volt is the potential difference 2 points of a conducting wire carrying a constant current 1 ampere when the power dissipated these points is equal to 1 watt.
So in the ordinary tri-cell or in the storage battery, chemical action causes positive charges to click on the positive terminal and electrons or negative charges to click on the negative terminals. So that's how it's means. Proceed. So this is the figure shown.
By convention, current is assisted to flow from positive to negative. So we have this, the positively charged, the protons, and the negatively charged, the electrons. These charges can build up on the surface of an object until they find a way to be released or discharged. One way to discharge them is through a circuit.
Alright, so let's proceed to the next one. Unit of electric resistance. Ito na
The ohm is the electric assistance between 2 points of a conductor when a constant potential difference of 1 volt applied to this point procedures in the conductor a current of 1 ampere, the conductor not being the set of any electromagnetic force.
The current stands for I that will flow in a direct current and electric current that flows in only one direction. So this is directly proportional to a voltage V and inversely proportional to the resistance R of the circuit. This equation expresses we have the basic form of Ohm's law.
So the formula of it is the current, or I, equals voltage, or V, over resistance, R. That is a current 1 is produced that is proportional to the electric pressure V and inversely proportional to the electric friction R, or resistance. So next, so
this unit resistance, which is the Ohm's law. First, we have an incandescent lamp having a hot resistance of 66 ohms is put in a socket that is connected to a 115V supply. What current flows through the lamp?
So to get the current, as we've shown to you earlier, the formula of it is I equals voltage over resistance. So the value of voltage here is 115 and the value of resistance is 66. So if you divided it, you're going to have 1.74 amperes. That's simple.
Yeah. So number 2, we have number 2 example, a bathroom heater draws 11 amperes at 120 V. What is the hot resistance?
So to get this, you're just going to change the formula into R equals V over I, or current, equals, so the voltage is 120 and the ampere is, or current is 11, and if you calculate it, you're going to have 10.91 ohms.
So number 3 example, how a household electric water heater is rated 220 V and 20 amperes. What is the unit's resistance when drawing this amount of current?
So what is the unit resistance when drawing this amount of current?
Yes.
The formula of it is R equals V voltage over current, and V is equal to, no, this is R. This is resistance. I'm sorry, we have mistake.
How many?
R.
Any R.
Yeah. So we
should ano. Volume. So it's R pala.
So to get the resistance, you just divide the voltage, which is the 220, divided by 20 amperes, or the current, equals, the resistance is equals to 11 ohms. That's all.
Alright, so I hope that will be clear. Proceed to the next slide. We have a George Simon the name after the German physicist George who in his treatise PBP published in 1827 describes measurement of applied voltage and current through simple circuits containing various lengths of wire. Yes. So here is the Ohm's law. Ohm's law states that the current through a conductor between 2 points is directly proportional to the voltage across the 2 points. Introducing the constant of proportionality, the resistance one arrives at the usual mathematical equation that describes this relationship. So let's proceed to the next topic, which is the circuit arrangement.
A circuit diagram, also known as an electrical diagram, elementary diagram, or electronic schematic, is a simplified, conventional graphical representation of an electrical circuit. A pictorial circuit diagram uses simple images of components, while a schematic diagram shows the components of the circuit as simplified standard symbols. Both types show the connections between the devices, including power and signal connection. Arrangement of the components, interconnections, and the diagram does not correspond to their physical location in the finished device.
So an electric circuit may be defined as a complete conducting path that arrives current from a source of electricity to a through-some electrical device or load and back to the source. A current can never flow until the sum of electrical units of circuit arrangements. We have the series circuits and the parallel circuits. We'll discuss the parallel circuits later, okay?
Series circuit is a circuit in which there is only one path of electricity to flow. There.
Battery is rated at 120 volt. The line resistance both wires is 0.0 ohm and the load resistance is 1.15 ohms. We will determine the A current flowing in the circuit and B the voltage across the load V over CD. So yeah.
So the current flowing is, to get that, you should divide the voltage over resistance is equals to VAB over RAB plus RBC plus RCD plus RDA equals VAB means the battery voltage. We have 120 over 1.2. So if you calculate it, you're going to have 100 and then the voltage drop across the load is VCD equals your current times R resistance CD equals 100 times 1.5 equals 115 voltage across the load resistance.
So that's the end of series circuits, and let's proceed to next one.
Parallel circuit. So the parallel circuit is a circuit in which there are multiple paths for electricity to flow. So to get that, same as the other formulas, current is equals to V over R, voltage over resistance. I is equals to 120 voltage divided by 10 resistance is equal to 12 amps. This is the branch 1. The branch 2 is I equals 120 over 120 is equal to 1 amps. The branch 3 is I is equals to 120 over 12 is equals to 10. So to get the total current, you just add all of it, the 3 branches. The branch 1, 12, the branch 2 is 1, the branch 3 is 10. If you add it together, you're going to have 23 amps total current. That's all. And this is the end of our discussion. Thank you for listening. Again, I am Rizabilia Pahanonot.
And I'm Julian Paragatos,
your reporters from topic A.
Thank you so much. Bye.
Thank you.